In this question, we're told that a and b are integers, and the question wants to know whether a plus b plus 3 is an odd integer. Now, when it comes to odd numbers and even numbers, I think there are two good ways to think about that, and we're going to use both of those ways for this question. The first way is the way that I think most people think about it, which is an even number is a number that is divisible by 2, or in other words, it's a number that has 2 as a factor, right? If you look at the prime box of an even number, it will have at least one instance of 2 inside the prime box. And an odd number is a number that doesn't have any 2's inside its prime box. It is not divisible by 2. The other way to think about odds and evens is as follows. In the world of divisibility by 2, an even number does not have a remainder. The remainder is 0. An odd number does have a remainder, and that remainder is 1. So again, the question wants to know whether a plus b plus 3 is odd. I would suggest subtracting 3 from both sides of that equation and just asking, is a plus b even? All right, because if a plus b plus 3 is odd, then a plus b, just that part, would be even. So the question wants to know, is the sum of these two unknown integers, is the sum of a plus b an even number? Now, given that a and b are integers, there are only two ways in which their sum would be even. Either a and b are both even, so neither of them has a remainder in the world of divisibility by 2, so therefore when you add them, there's still no remainder. A remainder doesn't just come out of nowhere. If neither of them has a remainder on its own, the sum won't have a remainder either. The other way to get a sum that is even is if both a and b are odd. Why is that? Well, each of them has a remainder of 1 in the world of divisibility by 2, and when you add them, the remainder of 1 plus another remainder of 1 make a pair that is divisible by 2. In other words, the remainder disappears. Why? Because we had two remainders that completed each other to the divisor of this world of divisibility. So we can rephrase this question to, are a and b both of the same type in the world of divisibility by 2? Right? If they're both even or if they're both odd, in either of those cases we get a yes. How would we get a no? Only if a and b have different remainders in the world of divisibility by 2, meaning one of them is even and the other is odd. Now, the first statement tells us that their product is odd, meaning their product doesn't have any factors of 2 in the prime box. Now, if the product of a and b doesn't have any 2's in the prime box, that means that neither a nor b has any 2's in those individual prime boxes, because if there was a 2 in the prime box of one of them, that 2 would appear in the prime box of their product, right? Because the prime box of a product has all of the bits and pieces from the individual prime boxes of its factors. So statement 1 is essentially saying, hey, both a and b are odd, and we know from the previous discussion that that means that their sum is even, and therefore this is sufficient to answer the question. We can go ahead and eliminate the answer choices that claim that statement 1 is not sufficient on its own, B, C, and E. Now, statement 2 tells us that a minus b is even, meaning that either a and b are both even, there was no remainder for either of them, and of course there's still no remainder when you subtract one from the other, or a and b are both odd, meaning they each had a remainder of 1, but when you subtract one from the other, the remainder of 1 gets subtracted from the other remainder of 1, and you end up with a remainder of 0. So statement 2 is telling us that either a and b are both odd, which by the way is what statement 1 said, or that a and b are both even. Now, from the previous discussion, we know that both of those cases lead to a yes, right? The answer to the question is yes, whether a and b are both odd or a and b are both even. And therefore, statement 2 is sufficient on its own as well, and we can go ahead and pick answer choice D. But before we move on to the next question, I just want to point something out here. This question is in the world of divisibility by 2. It's just odds and evens. The GMAT could have made this question harder by making it about a world of divisibility by a larger number. For example, 5. So if the question was, is the sum a plus b divisible by 5? And statement 2 told us a minus b is divisible by 5. That would be a completely different circumstance, because in the world of divisibility by 5, there's more than just two scenarios of yes, it's divisible, or no, it's not divisible and the remainder is 1. In the world of divisibility by 5, there's also remainder 2, remainder 3, and remainder 4. So it's a much more complicated situation. And if we're told that a minus b is divisible by 5, all we can say is that a and b have the same remainder in the world of divisibility by 5. They're either both remainder 0, both remainder 1, both remainder 2, both remainder 3, or both remainder 4. And only one of those cases would lead to a yes, a plus b is divisible by 5. And that's the case in which a and b both have a remainder of 0. See, if they were both remainder 1, their sum would have a remainder of 2 in the world of divisibility by 5. If they were both remainder 2, their sum would have a remainder of 4 in the world of divisibility by 5. If they were both remainder 3, 3 plus 3 is 6. In the world of divisibility by 5, they'd have a remainder of 1, right? Because you have a 5 plus another extra 1, that would be your remainder. And if they were both remainder 4, 4 plus 4 is 8. That's 3 over the divisor, 3 over the 5, so you'd have a remainder of 3 for the sum of a plus b in the world of divisibility by 5. So I just wanted to point that out because this is a great way for the GMAT to increase the difficulty level of a question like this. All right, now we can move on to the next one. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.